Okay, Assalamualaikum and very good evening to everyone. So this is the last part for the orbital overlapping diagram. So in this video, I'm going to show you how you can draw the orbital overlapping diagram for sp³d² hybrid by using SF6 and also XEF4 example. Okay, so by the end of this lesson, you should be able to draw the orbital overlapping diagram for the sulfur hexafluoride and also for xenon tetrafluoride. So we're going to start with the SF6. So macam biasa, the first step is you should draw the Lewis structure with the correct geometry and to calculate the formal charge for the molecule. Okay, so this is the Lewis structure with the correct geometry for SF6. And each of the atom in the molecule SF6 have the formal charge of equals to 0. So if you look at the structure, okay, we have 1, 2, 3, 4, 5, 6 sigma bonds. So since there are 6 sigma bonds around the central atom sulfur, so the hybrid on the sulfur is sp³d² hybrid. Now you already determine the hybrid, then we can draw the orbital diagram for the valence electron. Okay, sulfur is located on the group 16 element and in period 3. So that means sulfur will have a valence electron of equals to 6. Okay, so 2 of the electron will occupy the 3s orbital and another 4 of the electron will occupy the 3p orbital. Okay, if you look at the Lewis structure of the SSC, we have 1, 2, 3, 4, 5, 6. So 6 sigma bond, that means during the excited state you need to have, or for the hybrid to form, you need to have 6 single pair ataupun 6 unpaired electron. However, if you look at the ground state sulfur, we only have 2. Okay, we only have 2 unpaired electrons. So in order to create 6 unpaired electron, so we need to excite one of the electron from the 3p to the 3d, and we need to excite one of the electron from the 3s to the 3d orbital. Okay, so that means then for at excited state, the 3s now will have 1 unpaired electron, the 3p will have 3 unpaired electron, and the 3d will have 2 unpaired electron. Okay, so this unpaired electron come from the 3p, and this unpaired electron come from the 3s. So the hybrid on the sulfur is sp³d². That means we need to mix 1 s orbital, 3 p orbital and 2 d orbital. So kita akan combinekan ke-6 ini. So the s orbital ada 1 electron, the 3p have 3 unpaired electron and the d have 2 unpaired electron. So the extra yang kosong ini pun awak kena salin balik. This one we call it as the unhybridized 3d orbital. So the hybrid sp³d ni, each of the unpaired electron is going to be used to form a sigma bond with fluorine. Okay, fluorine at the ground state has 7 valence electron. So 2 of the valence electron will occupy the 2s orbital and another 5 will occupy 2p orbital. So this unpaired electron will form a sigma bond with the sulfur. So now we already draw the orbital diagram for the valence electron. We can draw the orbital overlapping diagram. So sp³d², the geometry is octahedral, that means have 6 loops. Okay, so nak draw dia, so you draw the first loop, second, third. Okay, so this is the third one. Sorry, awak kena make sure each of the sides is relatively the same. Okay, so lebih kurang lah ini dia punya shape sp³d², and then we need to label each loop with the name of the hybrid. And then you need to label the atom. So the atom is S. Okay, and then you need to draw the pair electron on each loop. Okay, since sulfur itu orbital yang akan overlap dengan fluorine adalah 2p orbital. So 2p orbital, the shape is dumbbell. So awak kena lukis dumbbell. Okay, so macam biasa, label lobe ini, letak dia punya elemen, letak dia punya overlapping je. So this is sigma overlapping. Okay, awak kena buat untuk setiap lobe tu. Awak kena lukis benda yang sama. So for this lobe, so 2p, this is fluorine. So this is also sigma. Okay, so for this lobe, okay, awak kena buat benda yang sama juga. Kita ulang sampai semua overlap dengan each of the loop dalam sp³d². So fluorine sigma. So this one also 2p fluorine sigma. Okay, same goes with this one. So 2p fluorine sigma, and the last one is, okay, so 2p fluorine sigma. Okay, so this is the orbital overlapping diagram for SF6. Okay, so the next example is Zenon Tetrafluoride. Okay, if you draw the Lewis structure and then calculate the formal charge, each of the formal charge dalam setiap atom ini, kalau awak kira, awak akan dapat equals to 0. And if you look at the xenon, you have 4 sigma bond and 2 lone pair. So 4 plus 2 is 6. So the hybrid on the xenon is sp³d². Okay, now we can draw the orbital diagram for the valence electron for xenon and also fluorine. Xenon is a group 18 element and located in period 7. So that means the valence electron will occupy the 7s and also the 7p. So xenon is group 18, that means have 8 valence electrons. So 2 of it will occupy 7s and another 6 will occupy 7p. So if you look at the structure of xenon, we have 4 sigma bond. 4 sigma bond, that means during the excited state, for the hybrid to be formed, awak kena ada 4 unpaired electron. Kan awak ada 2 lone pair. So maknanya dalam awak punya excited state mesti ada 2 pair electron. So tapi kalau awak tengok during the ground state of the xenon, semua kita ada pair electron. In order to create 4 unpaired electron, kita kena excite 1 electron from 7p and another electron also from the 7p. Kita akan excite dia kepada 7d. So ini akan masih 2. Sebab kita dah excite 1, so dia jadi single pair. So lagi 2 single pair tu akan masuk dekat 7d. Since the hybrid on the xenon is sp³d², so we need to combine 1s, 3p and 2d. So the s orbital have 2 electron, one of the p also have pair electron, and then we have 4 unpaired electron. So this one we call it as a unhybridized. This one we call it as unhybridized 7d. So this 4 single pair electron ini kita akan gunakan untuk form sigma bond dengan fluorine. So fluorine macam biasa group 17, 7 valence electron. So this unpaired electron ini akan form sigma bond dengan xenon. Lone pair ini adalah lone pair yang dekat sini. So kalau awak tengok molecular geometry itu, lone pair itu berada di atas dan bawah xenon. So waktu awak lukis orbital overlapping diagram pun dia mesti dekat atas dan bawah xenon. So since the hybrid on the xenon is a sp³d² hybrid, so we need to draw in the shape of octahedral. So kita akan draw in the shape of octahedral. So we have 1 loop, 2, 3, 4, 5, 5, and then the last one is 6. And then you need to label each loop with the name of the hybrid. So the name is sp³d². So after you label with the name of the hybrid, macam biasa kita akan lukis dulu pair electron. Okay, kita akan lukis dekat setiap satu loop tu, kita akan lukis a pair of electron. Okay, so macam saya cakap tadi, sebab kalau awak tengok dia punya Lewis structure, both of the lone pair akan terletak dekat atas, satu atas dan satu bawah. So maknanya yang sini dengan sini awak jangan overlapkan dengan fluorine. Okay, fluorine kalau awak tengok tadi dia overlap dekat 2p orbital kan, elektron dalam 2p. So bentuk 2p adalah bentuk dumbbell. So we need to draw the dumbbell. So one, so this is fluorine. 2p, make sure you label the type of overlapping. Okay, this one also another one. Okay, this one 2p, label fluorine, label sigma bond. Okay, one here. Okay, so label the orbital, label the element, label the type of overlapping. Okay, sama juga yang macam ni. So 2p, label element, label type of overlapping. So this is the orbital overlapping diagram for the Zenon. Okay, for the Zenon Tetrafluoride. Okay, I think that's all for orbital overlapping. So in the next lesson, okay, we're going to learn about the different type of intermolecular forces. So thank you everyone.